What if we could create stars? Stars are the engines of the universe, cosmic furnaces that shape solar systems, forge elements, and provide the heat and light necessary for life. But what if we weren't just observers of this process? What if humanity could create stars? The ability to generate such power could revolutionize space exploration, terraform planets, and even provide limitless energy. But how could we actually do it? 1. Artificial supermassive objects. The simplest way to make a star is to do what nature already does. Gather a massive cloud of hydrogen and helium gas, compress it under gravity, and wait for nuclear fusion to ignite. But to make this work artificially, we'd need a way to accumulate at least 80 times the mass of Jupiter, the minimum needed to create a small star. One possibility? Asteroid and gas cloud harvesting. Using massive fleets of robotic spacecraft, we could direct interstellar gas and planetary debris into a dense core, forcing it to collapse under its own gravity. If we perfected the technique, we could build entire solar systems from scratch, placing stars exactly where we need them. 2. Graviton Manipulation. Gravity is one of the fundamental forces of the universe, but unlike electromagnetism, we currently have no way to control it. If gravitons, the hypothetical particles thought to carry gravitational force, actually exist, we might be able to manipulate them. If we could amplify gravitational attraction at will, we wouldn't need massive amounts of matter to form a star. Instead, we could artificially increase the gravity in a given region of space, forcing gas clouds to compress and ignite. Mastering this would mean we could control not just stars but planetary orbits, black holes, and even the fabric of spacetime itself. 3. Warped Spacetime Generators. According to Einstein's general relativity, massive objects warp spacetime, creating the effect we call gravity. What if we could do the same thing artificially? A spacetime warping device could simulate the gravitational pull of a star without actually requiring its mass. This might involve exotic materials like negative energy or dark matter, things we don't fully understand yet but could one day harness. By bending spacetime in the right way, we could squeeze interstellar gas into high-density regions, causing nuclear fusion to begin. This wouldn't just be useful for making stars. It could redefine space travel, allowing us to control gravity itself. 4. Black hole compression. Perhaps the most extreme method of star creation would be using a controlled micro-black hole. A tiny black hole, carefully maintained, could act as a gravitational core, pulling in surrounding gas and matter. Given enough mass, the immense pressure at the event horizon would force nuclear fusion to begin, essentially forming a star around the black hole itself. The danger? If we lost control, the black hole could consume the entire system instead of stabilizing into a sun. But if we perfected the technique, we could create energy sources far more powerful than anything in nature. What would we do with this power? If we could create stars, we wouldn't just be lighting up dark corners of the galaxy. We'd be engineering entire solar systems. We could terraform lifeless planets by placing new suns in just the right spots, extending the habitable zones of existing star systems. We could even build artificial stellar nurseries, ensuring a continuous cycle of energy production for future civilizations. But with such power comes enormous risk. A single miscalculation could trigger a runaway fusion event, an uncontrollable gravitational collapse, or even a man-made black hole devouring everything in its path. Would we have the wisdom to use this ability responsibly? Or would our attempt to become creators of light plunge the universe into darkness?